What are appropriate DH parameters for robot design? Imagine building a robot arm that moves precisely and smoothly. To do that, you need a clear way to describe how each part connects and moves. That's where Dynavit-Hartenberg parameters come in. They are a set of numbers that tell you how one link relates to the next in space. These numbers help you map out the robot's entire structure. The first parameter is the link length. It measures how long the segment is between two joints along the normal line that connects their axes. Think of it as the length of the arm segment between two pivot points. The second parameter is the link twist. It shows the angle between the axes of two joints, measured around the common normal. This helps account for any twisting or rotation between links. Next is the link offset. It is the distance along the previous joint's axis to the point where the next link begins. For robots with sliding joints, this value can change as the joint extends or retracts. The last parameter is the joint angle. This is the rotation around the previous joint's axis, which is especially important for revolute joints that spin. For prismatic joints that slide, this angle stays fixed, and the offset changes instead. Choosing the right DH parameters means making sure they match the real physical dimensions of your robot. You want to assign coordinate frames carefully so that when all joint variables are 0, the axes line up logically. This makes controlling the robot easier. You also need to consider the actual size and shape of each link, including manufacturing tolerances. Sometimes, you might need to fine-tune these parameters after building the robot to get precise movements. It's important to remember that for different joint types, the parameters change roles. For revolute joints, the joint angle varies, and the offset stays constant. For prismatic joints, the offset varies, and the angle remains fixed. When axes are parallel or intersecting, special rules help define the parameters correctly, ensuring the model stays valid. Engineers use these parameters to create transformation matrices that describe how each link moves relative to the previous one. Multiplying these matrices along the chain gives the robot's forward kinematics, which tells you where the end effector is based on joint positions. In robot design and development, selecting accurate DH parameters is key. They help build reliable models for simulation, control, and calibration. When these parameters match the real robot, it becomes much easier to predict how the robot will behave and to program it effectively. This systematic approach is fundamental in robotics engineering, especially when working with complex kinematic chains and precise movements.